introduction of myself, which I've got set up here. So a bit of history. I've always kind of been interested in animals and the environment since I was young, and kind of the same thing through high school, university, studied zoology at Otago, and then kind of always had this passion for conservation. Ended up coming up to Auckland to do a PhD, and I kind of always wondered, I didn't know what kind of got me on this track, or I kind of just felt like it just all worked out. And a couple of years ago, my mum found a self-portrait I did when I was 7. You probably can't read it, so I'll try and read it out to you. But it's me holding a penguin, grand or something. I think I'm saying ouch because the penguin bit me. But it says, I'm a conservationist. Conservationists are like scientists, so they look after animals and their environment. I like my job because I like animals. I like going deep down, and I like to look after animals too. I do this job because I get paid well. It's obviously very naive of me to think. And it's very fun as well. So kind of the story behind that is I've always been interested in the environment, but I don't know kind of how I ended up here, which is cool. Studied at Otago, that's where I'm from, and moved up to Auckland a couple of years ago for my PhD. And that's me holding an oi. Who here knows what an oi or grey-faced petrel is? Hands? Lots of people. Anyone seen one or heard one? Yeah, a few people have done that with me, which is cool. So I'll start a little bit more generally. So grey-faced petrel or oi are what we call a burrowing seabird. So we know forest birds mostly make nests up in the trees. These burrowing seabirds, they dig holes kind of like rabbits would. So when you walk through the Waitākere, you might see these big holes. Could be a rabbit burrow or it could be a grey-faced petrel burrow. And that's where they go and then they lay the egg and raise the chick. There's very few burrowing seabirds that still do this on mainland New Zealand. These include grey-faced petrel, the Westland petrel down South Westland, Hutton Shearwater in the Waitākere Mountains, and some city shearwater kind of down to the South Island, kind of Otago, Catlins coast. So most of these burrowing seabirds breed on colonies offshore islands where they're free of predators. So we kind of know the history that Māori and Europeans brought kiori and kuri, and then kind of rats, stoats, cats, hedgehogs, all of those things, which our burrowing seabirds being on the ground didn't really like, so they've been driven off our mainland onto these predator-free islands. But invasive species, these predators, pests, are still the number one threat to burrowing seabirds across the globe. So this kind of brings me to this idea that what we need to do is remove these pests, right? And we've talked about suppression already. So the idea is how do we look at that? So a little bit more on kind of grey-faced petrel. So they're kind of special in a way that they breed over winter, whereas most of our burrowing seabirds breed over summer. So that's maybe potentially why we find them on mainland, because we have lower levels of rats and stoats over that winter period. So what they do, they come and do some courtship in April and May. So I encourage you next year to go out into the points out in the Manukau Harbour or places like Piha, and just sit for a night and hear the birds coming in. It's a really amazing experience to hear their sound. They do that, do their mating, then they head back out to sea for a long period of time, where that female really fattens up and develops that egg. Then it comes back in around June, July to lay that egg, and the incubation takes 55 days, and there's coordinated co-incubation by the male and female. And they do kind of 10 to 14 day stints, where they just sit on the egg, do nothing, keep it warm, until their mate comes back, and then they switch over. Which is quite impressive really. And then eventually the egg hatches, and it looks, that kind of little wet chick takes a few days to get fluffy, and then it's guarded for a few days, then both adults leave, and then they just do return trips to feed. Come back at night, feed the chick, go back that morning and out. So that chick spends 120 days by itself in that burrow. So obviously we know things like rats and stoats, they like to be on the ground. They use olfactory, they smell, so they smell where these birds are, and they can just go down those burrows, grab that little chick and take it out. So again, that's why predators are a really big threat. And then eventually in December or January, that bird will come out of its burrow and then jump off a cliff and not be seen again for 4 or 5 years. Goes somewhere else, feeds on fish and squid and all those sorts of things, and then hopefully one day comes back.
Do they come back to their nesting?
Yes, they do. So that's called Waitākere, so where they come back to where they were raised. So not sure exactly what the percentages are, but it's up toward 95-99% will come back to where they're from, which is really interesting. So it means that in terms of predator control, if we can protect one place for a long period of time, those birds will come back. Whereas that's the issue with other things like forest birds. You protect Auckland Park, this area here, Waitākere decide that they want to nest outside of that zone. It's pretty difficult to then move your whole operation outwards. Whereas this, you can go, I'm going to protect this area here for the next 30 years, you can get those benefits. So the current distribution is across kind of the whole northern North Island. So when we look at that, that looks pretty impressive in terms of distribution. But if we have another look more at, so hear the sound. So this is what they sound like at night when they're coming back on land. Anyone recognise that call? Yeah, before?
Is it the babies walking?
No, so it's the adults when they're coming back, so they're flying, there's some flying around and on the ground trying to figure out who's there, how many birds are there, where they're laying sort of thing, so that kind of mating sort of call.
Can they swap?
So I will stop that so I can hear. Sorry, what was the question?
That was a joke. I said, can they swap puppies?
So yeah, when we kind of visually look at this, the population, which the population sits at around 200,000 breeding pairs. So while it's not an at-risk species, it's still important kind of long-term to use, and it's a really good model species because it is found on mainly areas and it potentially is expanding. But also, there's only about 70% of the population is on 3 kind of island groups on the east coast. So while the distribution is really large, the majority of those colonies are actually quite small, kind of under 1,000 or 2 breeding pairs. So it means that if something were to happen in these areas, we could lose like a large chunk of the population. And there's something like approximately 20 mainland colonies. We've got some up north at Breamhead, down into Papanui, out on Mount Maunganui on the east coast, and then on the west coast, places like the Waitākere Ranges, and some other spots further south, in Raglan and Taranaki. So there's a few scattered over, but they're not very large. They're usually under 100 burrows, 100 breeding pairs, if not less. Just check my notes to make sure I've gone over everything. You can also see that on the east coast, that's where the majority of the population is, and that's quite interesting. Financially, it's because there's more islands on that side, so more of those areas are predator-free. Whereas you pop over to the west coast, very few islands for those birds to be on that are predator-free.
Is it also there's more further south?
No, so that's the most southern range are those, I think it's the Cape Kidnappers on the east coast, and then Taranaki on the west coast. So it's similar. You've got other burrowing species that would likely be further south, but yeah, all of the Great Bass petrel in that kind of upper half of the North Island. I'm here at my sites where I'm doing my research. So I'm doing Waitākere Ranges, where we are now, and also Mukilemu Island, which is a predator-free island in the Kaipara Harbour, so one of the few islands that we have that we can make more or less predator-free. A little bit more about the Waitākere Ranges. I'm sure you're all very familiar with this, but as you go through, we've now changed from those circles being colonies to now the individual burrows. So you can see that they're densely aggregated around the kind of popular beaches. So if we go, there's some in Taranaki, I'll look at in a bit more detail in a moment, down Cornwallis, Whāpupu, Paripari, South Piha, North Piha, Te Hinga, and Muriwai. And then more or less, as you can see, pretty much all along the coastline. So wherever there has been pest control or there's suitable habitat, they tend to pop up. So over time, hopefully we can fill that gap so it's just blue all the way around. And I was fortunate to mention they're quite a coastal species, so they're usually found within 20 to 50 metres of the hence we don't have them going further in. Other burrowing seabirds would be found further inland, but not at the moment. And if we go a little bit closer and look at Waitākere, there's around 15 to 20 burrows in 2 areas. Waitākere Reserve, which I assume is just west of here, west-north, that way, somewhere close by, and Waitākere Reserve as well, which is just around the corner. So those are predator controlled by South Tasmanian Neighbourhood Network, which is great. Especially Tony and Dave, Tony Dunn and Dave Blake, they are looking after Waitākere Reserve. They've got some cameras there to look at the pests and the birds to see what's happening there. And they've been doing quite well for the last, I think, 4 or 5 years, is that right? Yeah, so we're doing really good predator control there, which is hopefully growing up that population. But as I said before, some of those birds, those chicks leave 5 years ago, so you might do lots of work, now, but it's not going to really pay off until you get those birds coming back and the population getting bigger. That's a really good start at the moment, which is cool. So go a little bit into predator control. I won't talk too much, I won't preach too much, because I'm sure you're all on the same page. But what our current approach is what we first want to do is we want to eradicate, and that's what we've done in lots of predator-free islands out on that east coast. Is get rid of them. So this is limited to offshore islands or our small mainland reserves, places like Waitākere, Waitanui, those places we can put a fence in and kill everything inside. So if we can't do that, what we normally go for is control called this idea of suppression. So we want to reduce and maintain to a desirable level. But often this is looked at as low as possible is what we desire. And we think about that. What is a desirable level? How do we set those? And my kind of argument and the idea of the thesis that I'm doing is that what we want is to get it to a desirable level where we get biodiversity outcomes. So we want more insects, we want more birds, but we want to be able to measure that. With forest birds, we can do 5-minute bird counts over time to see how that goes. Not sure how we do insect stuff, but I'm sure Dave will know. But we want to see that we're getting benefit from it, right? So that's kind of what I'm looking at. And how I'm doing that is using this idea of a density impact function, which sounds quite technical, but it's just a term for a relationship between pest density or pest number and biodiversity impact. And when we think about this, and we think about predator control in general terms, we often think that there'll be a proportional result. For every rat we remove, every stoat we remove, we actually will get a 1-for-1 increase in that biodiversity outcome, the number of birds, the number of insects. We find in New Zealand that that's not often the case. And we have different relationships, like moderately resistant. You can see that's a different curve, so it's not hitting that proportional, or something that's more like lots of species is highly vulnerable. And the main thing here is that we can reduce that predator abundance at the same, well, other way around. If we have a biodiversity outcome in mind, we're going to have drastically different predator abundances for the different species to actually get that. So this leads me to what I'm specifically doing with my research. And then the first question is, what is the relationship between predator abundance and grey-faced petrel breeding success? And to do that, I'm looking at creating one of those density impact functions. And then my second question is, what level must predators be reduced to for grey-faced petrel to breed successfully? So what are we aiming for? What is the biodiversity response? And this is going to be called maximum allowable density. I'll talk about that more in a little bit. Then finally, how can community groups like yourselves be more effective and efficient with their predator control? So how do we turn this into real terms that people can use rather than just us scientists saying, this is what we want, go figure it out. So do a little bit more about what I do. I'll play a full video like water. So for my biodiversity outcome, I'm looking at grey-faced petrel breeding success. So what I do is count the number of chicks that fledge, or assume to fledge, and I divide that by the number of breeding attempts. So what I do is I monitor these breeding attempts from that start in June, July, all the way through to December. Now I've chosen a really intensive monitoring, so I do it every 2 to 3 weeks. And I'm doing between 100 and 200 burrows at that amount. So we look back to those areas. I'm at Muriwai, taking a Piha, Karikari, Whatapu and Cornwallis, more or less every 2 to 3 weeks. Then Mukurimu I go to 3 times a year, just a couple months apart. And I'm doing some work down in Taranaki as well, going 3 times a year. The idea of doing this every 2 to 3 weeks is that we can hopefully figure out where the most vulnerable period is and when we're losing chicks, so we can also know when to do those pulses as well. And I do this by using, I don't always stick my hand down, I've got like a boroscope, so it's this big cord with a light at the end that live feeds to my phone with the camera, and I stick that on a stick and stick the stick down and then see what's in the burrow. Might sound simple, but sometimes it can be very difficult. I aim to do about 20 burrows per monitoring site, if there's that many available. Some of the smaller sites don't quite have that many, hence why Tarangi is not being monitored. We've only got 3 or 4 accessible burrows, and the other ones are somewhere we can't really figure out how to get to. So all those notes. And at the same time, I'm measuring predator abundance. So I'm doing this with 2 methods: tracking tunnels, as we've briefly talked about, trail cameras. If the trail cameras, they're taking photos of something that moves in front of them. I have 2 of these okulurs you can see on the screen there, and there's one that attracts stoats and mustelids, and one that attracts rats. And then camera takes photos of those, and then you count those detections and you divide it by the amount of hours that camera was active to get some sort of index. So it gives you a number between usually 1 and 20 or 30. So it's a nice number then, 0.02 to look at. Lots of pictures, over probably 100,000 photos that I go through manually at the moment. So do the little chunks, so doesn't take too much time. I'll kind of go back to a bit broader. So we were talking about how those East Coast sites have the majority of our grey-faced petrel. These West Coast sites are actually really important. So a little bit of study by previous researchers have looked at breeding success, back into the 1980s. So I've gone through a lot of that and had a look and put them into kind of 6 groups. So we've got either no predator control, or predator free. So the white boxes are no control, the blue boxes are predator control, and then the green are predator free. So as you can see there, you can't see any of the white boxes because anywhere where there's no control, the success is really low. So these ones here, a couple are getting some for both sites here, and then you can see the control actually doing quite well. But then the big thing to look at here is those green boxes on the East Coast, even predator free sites. Their kind of average breeding is under 50%, and whereas on the West Coast, it's up kind of near 80 to 100%. So the thought behind this is, on the West Coast, it's easier for the adults to feed out in Tasman Sea. They don't have to fly as far, and they have better access to more food. So what that means is they can come back, feed those chicks, and those chicks, all survive if they don't get depredated by a stoat or a ferret or a rat. Whereas on the East Coast, they think there's less access to food and it's further away, so sometimes that chick dies of starvation. So even though there's no predators eating them, they can't all be looked after by the parents. So the key thing here is we can't really give them more food on the East Coast, but what we can do is we can make more of our West Coast sites predator-free or predator-suppressed, and that still works quite well, as you can see from that control. I'm just going to double check this. So I'm going to go through some of my data, but if we add that, we can see that now the control on the West Coast site goes from 0 to almost 100. So we can then see that different types of controls and intensity of control can make a really big difference. If you have not so good predator control, you can still get 0%. But if you have really good predator control, you can get up towards 80%. So that really kind of, can't remember what it, but that difference is really important. So these are my results from last year for breeding success. You can see that basically Cornwallis, Kalikali, North PR, Tihinga, and Muriwai, and went through a predator-free site, had really high success, all around at 75 to 80% of the breeding attempts I followed were successful, and you can see at Waitākere really low in 0, unfortunately, and we'll go into that in a bit more detail. Then if we look at the averages of everywhere else and set those in, we can see that all of the previous work is the average of those breeding successes down to there is 0.35. So what I'm finding out here is way above the average for both East Coast predator-free sites and some of the West Coast sites that we looked at previously. So high to everyone in the white hats. A little bit of trail camera monitoring. This is really just to show, again, the diversity of sites. So a lot of our sites that we look at have reasonably low rat numbers, except for a couple that pop up. There's like Waitākere Island, some of the North Piha sites got more rats than when you look at Tihinga and even Tilingi. And then once again, stoats, you can see that some places have lots of stoats and some have none at all. So it's just more looking at the distribution, how it's different across the areas. For that, if we look at 120, which is that high North Piha site, that's 2 rats a day on camera. It's not necessarily 2 individual rats, but it's me going through photos and every day there's 2 rats coming up at least. And this is from July 2020 to April 2023, so almost 12 months. A little bit from a keyword. So this, I guess most of the suite of predators have been down here. We've got possums, rats, hedgehogs, the occasional dog, mice and cats. Most of those cats, I assume are domestic. You can see the collar. Probably not a massive threat to greyhound petrel. The big things to look at are feral cats, rats and stoats. And in particular Norway rats, which I'm pretty certain that's a Norway rat in the bottom corner. So those are the ones that we want to kind of knock down. And then if we look at the tracking tunnel monitoring, again we can see that there's quite a diversity. Cornwallis with 0 rat traps across the 40 tunnels we put out, which is quite impressive. Waitākere with the highest number of rats, and then the others all sitting around that 0.1 to 0.3. And we talked about 0.05 being the goal, so we can look and see that most of those sites are over that suppression goal at the moment. So next what I want to do is make this the impact function. So it's more fun about it.
On the slide, is it on the slide? Yeah. And then it's the red.
Here we go. Cool. So on this white axis here, up here, there's that great petrel breeding success. So it's 0 being bad and 1 being good. So you can see that most of these sit in a pretty good range from what we looked at before. And then on this x-axis we have the rats detected that per 1,000 kilometre hours. And what we can see is the site with lots of rats didn't do so well, but even a few rats actually is okay according to my data. And again, this is only 1 year's worth, and a lot of this is looking more theoretically what we want to think of is going on. Similar with the tracking, you have a bunch up here that are doing well, and one with lots of rats not doing so well. So here we can say that obviously looks like the more rats we have, the worse it is. Not the most scientific, but if we wanted to fit some theoretical curve to this, which is pretty much just been drawn by hand, it might look something like this. We could then potentially say that they're moderately resistant to rats. So if we have a few rats, that's okay. So once we get past some sort of threshold or tipping point, then the population starts to decline. This is also with what I'm collecting this year. It's obviously not finished. I'm waiting for the birds to leave in December, but that potentially looks like what's happening here as well. Some of the sites with lots of rats are not doing so well. So if we did the same with stoats, we can see that the place of lots of stoats, not doing so well. And then pretty much everywhere else there are no stoats on camera. But this here was one detection versus something like 4 or 5 detections. So I thought to say on the previous slide that this is the predator abundance on that use axis is just for a kind of 2-month period over August, September, where the chicks are most vulnerable, rather than that whole range of the year. And that's why we don't have at Muriwai there's lots of stoats, but they often pop up later in the season rather than during that key breeding season. So that's the difference to those. Here we go. Use this data. And here we can look at it and say maybe they're highly vulnerable. And this is a lot of relationships that we see with stoats and other birds that are ground nesting, things like Theo, blue duck. Just a few stoats can really wipe out the population. And that's again what I've seen this year. I've got another point that will sit somewhere around here. Waitākere still has lots of stoats, and they tend to be wiping out those populations of greyfish, unfortunately. This maybe a stoat that walks past and ignores all the burrows, or happens to kill the chicks in the burrows I'm not looking at. But yeah, more or less you need 0 stoats over that key breeding season. So next what we're going to do is our idea of maximum allowable density. So now we need to kind of set some numbers for what we want. And potentially if we look at the population size of each individual colony in the Waitākere ranges, and we think about some of the things like what is adult survival year to year, what are the juvenile survival, what are the return rates, do lots of stats, which is not very fun. But if we did that kind of and had a brief think, we think maybe something like 50% breeding success is what we'd want for population expansion in this area. And then we can use these theoretical curves, which hopefully next year will be real, and we can say where does that hit on the curve, so what we want to aim for. Then we can say we want to aim for something like less than 15 rat detections on the camera, something below 0.4 rat tracking rate, and then pretty much 0 stoats. So that's what we're saying. Yeah. But that's all good and well. If I ask you to run through what does less than 15 rats detected on camera look like, how do you get to that? I'd be really surprised if anyone could answer that. So what the kind of key to this and what we want to do is we want to say what is the minimum control effort? So control being predator control, how many traps, how many bait stations. So this is another kind of using the data from Catch IT and Trap New Zealand. I've looked at a number of rat traps, so that's anything like a dock or a victor. Those ones excluding things like possum traps or mice traps. How many are within approximately a kilometre of the colony? Again, approximate, because I'm going to tidy this all up next year with my data. Kia ora.
What does CH per 1,000 what?
So that's per 1,000 camera trap hours.
Okay.
So yeah, it's just an index number. So it's the number of rats on that y-axis and the number of traps along the bottom. We look at that and fit a more theoretical curve. We would say that it starts here and sharply declines. So it makes sense, right? If we put more rat traps out, we should have less rats. But where the sweet spot is, if we were to say, about 15 rats per camera trap hours goes back to 50% breeding success, which is what we want. So in these areas we want to be putting at least 40 rat traps within a kilometre. And that looks like about 100 by 100 metre grid, which we were talking about earlier, so it kind of reinforces that idea. And here we can go and tell there's people now. So that's pretty much me for my talk. A little summary. What I'm looking at is getting breeding success data for grey-faced petrel, as well as predator abundance data, and then I'm using it to create this relationship curve to see how many rats and stoats we can allow in our environment so that we still get grey-faced petrel at a high enough number, and then what does that look like in terms of number of traps, so we can get community, Auckland Council, how can we get them on board with kind of real targets, and then hopefully this turns into some more guided biodiversity management where we can put resources into one place and not overcommit and be able to use them across, because obviously we've talked before before about how much it costs to do these programs. If we can try and do the minimum in multiple places, we'll get more biodiversity outcomes as a whole. And then for the future, we're using grey-faced petrel because they're here, but we know that there are more burrow-nesting seabirds around. So we know there are things like flesh-footed shearwaters, black petrel and fluttering shearwaters around the Auckland area. And I've got images on my cameras. They're not designed to pick up birds, but they often tend to apparently walk right in front of them. So I've got a photo at Muriwai of a common diving petrel, and I've found some dead out there, so they're obviously floating around somewhere, looking for somewhere to nest, where they're at the Cox petrel indeed. So these birds are around, and if we can see what we need for grey-faced petrel, that is a minimum, or a maximum, then we can keep going down from that to get these more vulnerable species back into our environment as well. I'll just go a quick thank you to everybody. So there's lots of people involved in my project. I've got 3 wonderful supervisors, Jan Russell, Brendan, Dunphy and Podlanders that all work at the University of Auckland, as well as Todd works at Auckland Council, and he's great. Birds New Zealand Research Fund has helped fund some of my research. I work with Ngāti Whātua o Kaipara and a little bit with Kauro Amaki, so thank you for letting me do the work remotely, and as well as the Waitākere Rangers community, right? So you're the ones that are doing all the hard work, so I can come here and do this sort of research, and especially everyone that's been doing it for 10 or 15 years. We wouldn't have these birds and these numbers if it wasn't for you. Now I'm going to do a little plug while I'm here. I'm also looking at a bit more social research, so I'm wanting to see what people who live in the Waitākere Ranges think about native bird restoration. So I've got a survey that's open at the moment. You can come up and scan the QR code, or there's a URL here, or I can send you an email if you would like. I didn't grab any posters, I forgot.
I'll send it in an email to you.
Oh, brilliant, there you go. And the big thing is, it's great to have all of you here, but you're obviously already invested in the environment, and what I'm looking for is I want to get those people that aren't invested as well. So it's really important to see what the people that don't necessarily care about birds in the environment, what they think, because they're the ones that we need to get on board. We don't need to convert you, you're already converted. So if you know anybody else, if you're a part of other groups that are non-environmental, it would be great if you could pass these on, forward them on. I'm going to try and put them up in cafes and restaurants. Kia ora.
So, Michael, I don't know if you know Langholm at all, but I kind of figure if South Titirangi have got Oi and Wallace, why wouldn't we have it? And is it more likely because we're not tracking?
That's an interesting question. I did go out with Jan, who's here, and have a look around to see if we could find any. It's quite an inaccessible area, and I'm not too sure. I think a lot of it will come down to forest cover as well at the moment. They tend to like Urikawa and kind of specific slopes. But
Is that why we need to get rid of Phoenix Park?
No.
Oh, sorry.
No, it's all good. But I think it's also a lot of it is from historic. So we think that these populations have probably been there for a very long time in very low numbers because the adults are almost indestructible. A feral cat can take out adults, but anything else is the adult's probably going to win. So we think that they've probably been there, the whole history of Waitākere Ranges, but being pushed back to really small numbers. Because they're really long-lived birds, they live for 30 or so years. So they could be there, all the chicks could be dying every year, but they can still come back and keep trying. And even if a couple survive, it might just keep the population ticking over.
So maybe an easier way to work out whether we've got graphics on those two mechanisms is to listen for them.
Yeah.
Yeah, definitely. So I talked to Dan about it. It's probably better to get a group of people interested and go out every night for a week and see if you can get them. It's hard because they often might fly through the harbour rather than be landing, but they're pretty easy to hear on the ground as well. And that's when you can say, hey, I've actually seen one, and then I can reach out and have a look. I'll give you lots of questions. So did I answer your question?
Yeah, you
in
did.
enough detail?
Thank you.
Kauri Point.
Yeah, I know.
Kauri Point would be the place. Because I used to do the garden at the end of Kauri Point Road there. And I remember I think there was talk of them being in the cliffs there at one stage.
It kind of makes sense, eh?
But all that terrain's perfect, that Waitākere and Australia.
Yeah, and sometimes it's like when you walk, it's hard. You got to just walk and be like, oh, there's a burrow there. You know, when there might be only 4 or 5, it's really difficult to find. I know Tony was saying that other pitos, they're just in this random place along the cliff that you can't actually get to.
Yeah.
So they might just be not visible. We'll go Ian first. He seems really keen.
Just a question, Michael. Regarding light pollution, are there any particular areas in Waitākere which are bad for light pollution?
As far as I know, grey-faced petrel aren't as susceptible to light as some of those other seabirds. So, especially the cooks, they're found grounded quite often. But as far as I know, grey-faced petrel, not so bad because, for one, they don't fly over land. They're only coming into coastal areas. But not that I know of. I'm hoping that it's not a big problem at the moment, especially out west where we don't have a lot of big lights. Big
Can
city
I
lights.
say that the local board is working on parts of Waitākere University Dark Star Zoo?
Cool, that's awesome.
I might have missed it, but why is the development, why is it basically it's no good?
It's stoats. They're
So
just,
it's all stone basically.
I didn't go over it, but this year, because it fell last year and it fell the year before, so I went this year and I got poles and cameras and mounted them in front of the burrows to see what's happening. And it was every day the amateur stoat would come, go in, and the adult would still be there, sort of run off. It would come back and go and have a look and run off. And then obviously when that adult leaves the chick back south, they'll go in and then go back and there's no chick. So I don't get it on the camera. A couple of them I got pulling out, or it goes in because the cameras will take a 20-second video and have a minute or so off, so it doesn't fill up with content. So you'll see the stoat go in, then you'll see nothing else, and it'll be empty. So we've got that direct evidence of stoats taking them. So it's just what is there at the moment, and they've got good predator control, but they go around that caves walk on the kind of flat, and then they go up the Gibbons track, but all of the burrows are in between that area, up a bit of a cliff. So I think in there you've just got stoats running around and they be resident rather than moving through, whereas places like Muriwai or North Piha, maybe those stoats are more or less going through vagrant rather than hanging around. But again, that's all my anecdotal.
Can you also take large numbers of rats?
Yeah, and there's large numbers of rats as well, and that's kind of together, right? If you've got good predator control, you usually knock down both of those. I think Tony had his hand up before. Peter, sorry.
What I was wondering was, is there any correlation between the depth of a burrow and that was a response to predation?
So, as a great question, I don't think so, but I have no evidence to back that up, other than just my experience doing it. I know I've got a colleague that works down on Mana Island and Kapiti Island, on the celestial waters there, and they have, I think, on Kapiti, they have weka, and they have a massive weka population, overpopulated, and they have potentially a subgroup of weka that have been going in and killing the chicks in the burrows. So he's working on burrows that are up to 7 metres long, and he thinks that's because of predation of weka they keep digging. So potentially they're different species. There are often long burrows, but those are really hard for me to monitor, so I can't tell because my arm's this long, and I usually have a stick down the same length, and if it has a corner in it, or if there's more than 2 corners in it, so I tend to do burrows that are able to be monitored. So there's potentially bias in there, but because a stoat can just go down as far as it wants, I don't think it's it might be a response, but I don't think it makes a difference because of this. Good, Peter?
Yeah, I was just going to say that one of the, I wonder whether having colonies nearby is a way to get more colonies going.
Yeah, for sure.
Because what happened at Piha, I think, is that, that colony down at Tuaha
Yeah.
and maybe also at the Mawhara. And maybe on Taitomo, I'm not sure. But then when we started doing predator control on the South Cliffs, they came quite quickly.
Yeah, so it's definitely a big social attraction. So burrowing seabirds and seabirds in general like to breed together based on the idea that if someone else is breeding there, it must be a good place to go. So they kind of make these colonies rather than, I guess, an example would be forest birds that just find a good place for themselves to make their nest. So seabirds are like, oh, well, someone else is there, there's noise, I'll go try and find a mate. And second, it must be a good spot to hang out if all these other birds are here. So that's why we tend to see colonies get larger rather than potentially new places like Langholm developing colonies, because as birds fly past, first what they want to do is find other birds. Second, they might find a random one bird there and they might start. So it's a lot harder to start colonies, but it does happen. And the other thing with that is often you can get, the bigger you get colonies, they start to suck into little colonies. They get so large. You see that on islands. The big islands will start to suck in populations from the smaller islands. So those large islands might increase in size, while those smaller ones might decrease.
Can I just ask about the impact of the cyclone? Because a lot of the cliffs all along, just coming from Pika, Taitomo, Marifara to Waitākere, the cliffs fell off, and I've seen a helicopter flight from Murua along, and it's happened all along here.
Yeah.
What's that going to do in terms of losing barrows or, I don't know, it happened on the 14th of February?
Yeah, so the good thing is it happened in February when there were no birds in burrows, so it wouldn't have had any effect on last year's breeding season, so the only impact would be on this year's breeding season. There will be less burrows potentially if they've gone through areas where there were burrows, which in theory would just increase competition between grey-faced petrel for burrows, and it might decrease, this year and next year's total number of breeding attempts because there's less areas to burrow in. But birds can also, they dig burrows, so maybe I don't know how long it takes them if they can do it in a season, in a month or two, or if it takes a couple of years. There's also lots of unused burrows. Not every year every burrow gets used. There's all sorts of different reasons. One partner might die, the bird might get lost or something. So I still go around and find empty burrows, so there should still be room for these birds to come back.
You do wonder though, going forward, as an impact of climate change, which I don't think anybody predicted, what that would do to the longer term.
Yeah, for sure. And I guess the big thing is having more resilient coastlines, which have bigger trees, more mature forests, which we're all working towards as well, replanting and protecting. Because it's all of those, I guess, the shallow rooted things that go down.
Well, it would be my observation that a huge number of bird barrows went down, everything went down.
No.
If you look at Pika or Marifara, everything went down.
Well, around here too, same thing.
Pardon?
Around here, the same thing, big.
And it was really surprising that those very big long bird barrows went.
Yeah, true. But I'm not too sure looking forward, but hopefully it doesn't have too much of an impact.
Thank you, Michael.
I'll be here after.